Hey everybody. This is my first time doing YouTube Live, so forgive me if this doesn't come out. I'm Jenny Sue Flanagan of Just Simple Science, and during this time when schools are off, I'm just going to come on 3 times a week, Monday, Wednesdays, and Fridays. Try to be at around 10, between 10 and 11. Actually, I'll probably go live on Facebook at 10 and then do YouTube at 11, just to kind of share some of the Just Simple Science activities and experiments you could be doing with your kiddos at home. Um, During this time, really the most important piece is having your children ask questions and make observations and just have fun. Learning's going to happen naturally. So I want to share with you this activity that's all about ancient civilizations and science, and it deals with Greece. So we're actually going to use an activity that I call the strength of paper, and then I'm going to connect it to just how the Greeks designed some of their buildings and looking at the forces and how they learned to overcome the forces. So with this, materials you're going to need some computer paper, and you're going to need some books that are about the same size, same weight. And so what you can do is you can have your children find the mass, find the weight of this book, and that way they have a starting weight. And then what you're going to want to do is, the first thing is you're going to want to make your first column. So literally I just made a square column here, and basically all I did is I took a piece of computer paper and folded it into thirds, and then took and did the same thing with a second sheet, and then put it together and taped it here at the top and in the center and at the bottom. And so we have our column right here. And so then what you're going to do is the investigation question that we're trying to have our kiddos answer is, how many books will a square column made out of paper hold? They don't know the answer to that question, so they have to do something. So this is what I like to call descriptive research, because we don't know the answer to that question unless they've done it before. I'm not going to have my kids make any predictions because they don't really know what's going to happen. And so then they would just make these random guesses. And so I'm just going to have them make observations of what happens when I take and place books on this square column. Now, the other piece you want to have is just get a notebook. You can easily staple together some notebook pages, make a science notebook. It doesn't have to be anything fancy. The biggest piece is you want kids to make observations. So if you all can see, again, I'm using my computer here as my video screen. So look here on this side over here, and you can see it here, how it's bulging out. So you want your kids to actually make observations of that. Where do they see the column reacting to the weight of the book placed on top? So remember, gravity is a force that's pushing up on this tabletop, which is ultimately pushing up on the paper column, but this weight of the book is coming down on the column. And so I'm just going to stack up my books. So there's 2 books. So again, if I have the weight of one book, now I can have my kids actually do some simple math where they're adding the weight together. And then again, making observations. So what's happening with our column? So again, you're going to continue doing this until the column fails. And when it fails, when it actually buckles or topples over, you want to record the last book, not the book that actually made it fail, but what was the total number of books before it failed that it held. Okay, and then, so that's just simple activity, right? Descriptive research to answer the question, how many books will a square column hold? So now I want to turn it into what I like to call a Just Simple Science experiment. And so I simply asked, my kids, well, what could I change about these materials that might make a difference in the number of books that it can hold? And so I have my kids go through and generate different ideas. What I'm going to lead them to, I'm going to guide them to change, is the actual shape of the column. And so from the square column, I could have them make a triangle column, or I could have them make a round column. And so now I'm going to go through and I'm going to keep everything the same. So this is my first activity that I did. So we're going to kind of compare it to this. I'm changing the shape. So that's my independent variable, right? I'm manipulating that variable. I like to tell teachers when I'm working with them is I, as the researcher, am choosing to vary that piece. So that's my independent variable. I'm going to use the same books. So these are all my constants, right? Same paper, same books, same surface that I'm working on. And the only thing changing then is the shape of the column, right? So I go through and I do the same thing. I actually place the book on the column and wow, you can see that triangle one didn't even hold one book, right? So, and where did it buckle? Making observations and then recording that. So they go through and they test it out. What we know and what they'll find out later is that the round columns are able to handle the compression forces better. And so it equally distributes that weight that's pressing down on that column. And so that shape makes a difference. Are there other shapes that could make a difference? Don't know. It's a great way for your kids to try it out. So again, just a simple connection to ancient civilizations, quick little activity, and then turn it into experiment by having your kiddos brainstorm to change the shape of the column. So once they do the shape, what other experiments could they do? They could change the type of material that the columns are made out of, right? So maybe they could change it into cardstock paper. And will that actually make a difference? The other piece they could do is they could change the shape of this column, the round one. What if it's a tighter column, smaller, and there's not so much open space? Does that make a difference? What if I filled this with a substance, right? Or a material in here to give it a little bit more rigidity? Would that make a difference? So again, the whole point of this is you want your kids just asking questions and then designing that test to find an answer for that question. Remember, even if that experiment doesn't come out the way that they thought it might, it's not a failure. What other questions could they ask? What other things could they test? We want to really try and instill in our students that it's not a failure if something doesn't happen the way we thought it might, but rather from those failures, we could actually learn some more things by asking more questions and testing some things. So again, be looking out on Monday, Wednesday, and Fridays. On my YouTube page, I'm going to be sharing some just simple, what I like to call just simple science activities. Check out my Facebook page, Just Simple Science. I'm posting actually the link over there, and I will post it here as well if you want just a quick rundown of the activity for it. But we'll get through this. I know that a lot of my friends are at home and they're teaching their students for the first time, their own kids. Look, we're going to get through this. And we'll just help each other along the way. So thanks for joining me today, and I look forward to seeing you later on Friday. All right, have a great one. Go Science.